Hello and welcome to this part of our today's FLC discussions. In this part we are talking about use cases and value propositions of OPC UA and especially OPC UA FX. My name is Beudert and I'm Marketing Director for the OPC UA FX program in the Industry BU of Schneider Electric. I'm based in Marktheidenfeld in Germany. I'm a supporter of OPC UA technology since the days of Ole for process control. And together today we will explore how this technology is transforming, has evolved and is transforming industrial communication and automation. As I said, I was there in the beginning and now since a few days back to OPC. From OPC DA, where I started, OPC UA was developed to address the limitations of COM-DECOM with modern web services technologies, overcome and introduce a platform independence. Now it was possible to include OPC and running OPC on Unix, Linux systems, controllers and intelligent devices. And last but not least, OPC UA introduced advanced information modeling capabilities, allowing to do more complex and detailed structures. In 2016 to 18, the OPC UA field level communications were introduced to extend these already famous and very successful OPC UA into the field level of industrial automation system. It introduced real-time deterministic communication at the field level between sensors, actuators, controllers, and it aims to unify industrial communication by replacing proprietary field bus systems with a vendor-independent and interoperable standard. The OPC UA FX, a subset of FLC, focuses now concrete on the controller-to-controller and controller-to-device communication. Now let's take a look what I will present, the challenge of integrating machines, production lines and devices within a plant from three different perspectives. The first perspective is from the end user's customer's point of view. The second use case goes a bit up. It's how can I access as a data analyst when for AI use cases, and the use case 3 is the machine integration from the OEMs, from the machine builders perspective. What are the challenges of machine line device integration? The automation industry has a number of these challenges that impact its efficiency and its productivity. One of the most common use cases is that the projects are going over the budget. Unexpected cost changes during the development process often lead to expenses that exceed the initial estimates. Another significant problem is project delays. Technical complexities and challenges in system integration can cause schedules to slip and jeopardize deadlines, but also increase operational cost. Finally, a great deal of commissioning time is spent identifying, resolving issues, and especially true when it comes to machine integration, where ensuring compatibility and synchronization between different components often requires an extensive and detailed intervention or engineering as you like. So let's first have a look from the end user's point of view. What an end user wants. He wants to be able to easily and cost effectively integrate and connect machines and equipment from different vendors. This statement highlights the importance of simplicity and cost efficiency when it comes to integrating equipment from various suppliers from the perspective of, as I said, a plant operator or an end customer. Let's have a look on our bottling filling line. Here we have a multi-unit system which offers various capabilities, including washing, filling, capping, labeling. The integration of these units has traditionally been handled by the machine builder, system integrator, or the factory plant owner. But how can these machines collaborate effectively? Until now, achieving such an interoperability between machine modules, even with OPC UA, has been very challenging. I remember times when I was with the OMAC, we were talking about PECML, and we had the idea of exchanging machine study between machines and which were equipped with different PLCs of different suppliers, and we said, yes, let's do OPC UA. But at that time we had just OPC UA, and we needed a client which is doing all these exchanges, and this was not available at that time, and so we had to go. So we had to use a lot of engineering to make this happen. So that means this requires a lot of engineering effort, and that's exactly where OPC UA FX steps in, enabling machine module interoperability without adding extra engineering overhead. We later dive deep into these technical details and how it works, but for now let's look on the use cases itself and on the benefits. So first of all, what OPC UA FX is bringing is, thanks to its standardized communication layer down to the field, machines and devices from different manufacturers can interact seamlessly. But on top, OPC UA FX enables seamless data exchange from the field level all the way to the cloud, enhancing control and monitoring of production processes. And last but not least, reduced engineering effort. Implementing OPC UA FX minimizes the need for extensive engineering work and simplifies communication between machine modules. Model-based configuration using standardized information models has a profound impact across all project phases, from planning, commissioning up to the maintenance. And this is what we try to highlight here, that you really drastically reduce the time you have when you use OPC UA FX. Let's have a look to the use case 2. What is in for the data analyst? And a data analyst would like to be able to securely access data from any controller or device to identify opportunities for improving the production process. Having the flexibility to adapt data to his specific needs without relying on support from the machine builder or for the system integrator, this is where he dreams from. If you once have done an IIoT project, you know that the highest and the biggest difficulty is about how to get to the data. That's always the tricky thing, the tricky part in this game. So let's look at the trends in industry automation. And today everybody is talking about artificial intelligence. And we are in a good starting position. We have already 43 billion connected devices. And we have the potential to leverage predictive automation and product optimization with that. But only about 20% of these connected devices and 20% of the data they generate are currently used for this kind of analysis. So that means there is an enormous untapped potential, which is represented by the CAGR of nearly 40% over the coming years. So with this AI and with this analysis, we can do predictive maintenance. We can do product optimization using real-time data analysis to pinpoint inefficiencies and so on. We can do quality control, implementing computer vision to detect product defects and so on. And last but not least as well, process automation, handling repetitive tasks automatically, and allowing human beings to focus on higher value work. But how can OPC UA support this shift? The key advantage of OPC UA-FX lies in its ability to seamlessly provide multiple data models simultaneously, and these models enable us to leverage data in a simple and standardized way for a wide range of future analysis, whether for predictive maintenance or what I said before. Even when data originates from disparate systems with unique architecture or proprietary formats, OPC UA-FX allows us to analyze these systems in parallel without requiring complex custom integration. Crucially, this isn't limited to PLC-centric workflows. We can directly access data from sensors and edge devices themselves, bypassing the traditional bottlenecks, and all of this happens without interfering with machine or plant operations. So means no downtime, no disruption. Plug and analyze capabilities is powered by OPC UA-FX. Configurable communications, not engineered communications. In short, we are looking at a truly transformative shift. Engineers and operators gain granular data access and interoperability, while system integrators save countless hours previously spent on manually data mapping or protocol bridging. Now, the use case 3, we are looking from machine builders' perspective on this OPC UA-FX. As a machine builder, it would help me a lot to adopt our machines or my machine via a single vendor agnostic communication standard that works seamlessly across all types of application. Whether it's motion control, safety system, or other industrial processes, this standardization eliminates the need for custom interfaces or workarounds, and streamlining integration and future upgrades. But it's not just about simplicity. We also need to ensure that non-critical traffic like diagnostic data doesn't compromise the real-time performance of the machine. So far, from a communication standpoint, machine builders want. Let's have today a look at such an architecture. Each area uses its own strict and separate way of handling data, which is hard to change or connect with others. The data is scattered across different levels, making it tough to get systems to work together. Another problem is that many systems only work with certain devices, so adding new technology is expensive and tricky. This often locks companies into using just one vendor. Most importantly, the systems that run operations don't talk well with IT systems. This leaves gaps in information, slows down decision making, and makes it hard to use new tools like cloud monitoring or predictive analytics. Overall, these issues, rigid systems, scattered data, and poor communication make it hard for the businesses and for the OEM to be flexible and keep up with today's needs. Let's have a look how OPC UA can help in these circumstances. So with OPC UA-FX, first of all, what we heard before, bandwidth management and deterministic communication are baked into this architecture. This means high priority tasks. Think about precision motion control or emergency stops always take precedence, while secondary data flows adapt dynamically without disrupting the core operations. In essence, we are aiming for a best of both worlds scenario, robust interoperability across mixed vendor environments. This is the one, and coupled with the flexibility to handle modern data intensive workflows, all without sacrificing the speed or the reliability of the whole setup. All our systems use the same basic way to organize data, so it's easy to make changes or add new features without starting over. Data move easily from sensors to the cloud, helping us making faster and better decisions. Our system work well with many different devices, so we can add new equipment or work with another vendor without without big trouble. Our operations and IT systems talk to each other smoothly, so everyone gets real-time information. With OPC UA FX, important tasks always get the network speed they need, and less important data waits its turn. This keeps everything running safely and quickly. In short, it's easy to add new machines, growing the system and keeping everything up to date. So let's conclude how OPC UA can bridge the gap and make our future vision a reality. OPC UA FX creates a secure, interconnected ecosystem where data can seamlessly be collected and analyzed and shared across diverse systems and platforms. This open exchange of information breaks down traditional barriers between machines, devices, and software from different vendors, empowering companies to optimize their processes at every level. So it is an important backbone on which we, as well at Schneider Electric, can address and harmonize different tasks and different tasks from machine builder, from OEM part, from hybrid factory automation and process automation. With OPC UA and especially OPC UA FX, organizations can boost productivity, minimize downtime, and accelerate innovation by enabling real-time insights and automated decision-making. The result is a truly smart, connected factory environment where the vision of Industry 4.0 becomes a practical, achievable reality. By harnessing the full potential of their data, businesses can respond more quickly to market demands, improve operational efficiency, and stay ahead in an increasingly competitive landscape. That means this is overall the unique value propositions you see here: the data exchange, the data modeling, the secure, and the interoperability. All of that is a unique value proposition which we can offer with OPC UA FX. So far, thank you for your attention, and I'm there in the end for any kind of question. Thanks a lot for listening. See you soon.